Welcome to This Explainer. Today, we're tackling the ultimate cosmic mystery of our origins. Have you ever stopped to wonder, if our universe started with the Big Bang, what exactly was there right before it? Where did this whole massive event even take place? So let's just dive right in, because the answers, and honestly, the lack of answers, are absolutely mind-blowing. Before we even begin looking at the data, we really have to ask ourselves if there was some physical, dark place where it all happened. Did the Big Bang occur in a vast empty void? Was it just this endless dark nothingness? When we try to imagine the beginning of absolutely everything, our human brains naturally want to place that beginning inside of some pre-existing room or container, right?
Or perhaps our reality is just a continuation of an older, completely different cosmic realm that came before. Could it be that our universe is just the latest in a long chain of realities?
Let's push into an even wilder thought. What if the cosmic clock hadn't even started ticking yet? What if time itself literally did not exist? To even begin to unpack these incredible questions, we need to take a step back and completely rethink what we think we know. Section 1. What really was the Big Bang?
So most of us kind of picture this giant bomb going off, blasting matter out into a dark, empty space. But according to scientific understanding, the early universe was actually in an incredibly hot, dense state. The reality is that the universe didn't blow up like a bomb filling an empty room. Rather, the very fabric of reality, space itself, stretched out. Matter didn't explode into space, space expanded, and it carried matter along with it. The classic balloon analogy perfectly explains how galaxies drift apart without needing some outside container. Just imagine drawing dots on a balloon and then starting to blow it up. As the balloon gets bigger, every single dot gets further away from every other dot. And that is exactly how our universe is expanding. The space between the galaxies is stretching. But here's the major difference. Unlike a balloon which expands into the room you're standing in, the universe doesn't have an easily defined outside. Space and time are fundamentally bound to this expanding process. Section 2. Scientific evidence of the Big Bang.
Now, we don't just guess that this happened. In the 1920s, scientists like Edwin Hubble observed that distant galaxies were actually moving away from us. And the further away a galaxy was, the greater its redshift, meaning it was moving away even faster. This proved the universe wasn't static, it was expanding. And there's more. We can literally see the faint leftover microwave radiation from the early universe. It's known as the cosmic microwave background, or CMB. It's this weak glow spread almost uniformly across the entire sky, acting as a direct relic of the universe's fiery beginning. So the takeaway here is that by observing distant galaxies moving away and measuring the leftover background heat of the universe, we can essentially hit rewind on the cosmic clock. If things are moving apart today, well, running the tape backward means everything was closer, denser, and hotter in the past.
Section 3. What was before the Big Bang?
So we can wind the clock back billions of years, sure, but when we try to look at the exact moment of the Big Bang, or what came before it, we hit a major roadblock. Why? Well, because our current mathematical models just break down right at the beginning. You see, to understand the universe at its most massive scale, we use Einstein's general relativity, which brilliantly explains gravity. But to understand the incredibly tiny, incredibly dense singularity at the start of the universe, we also need quantum physics. And the problem is, these two heavy-hitting pillars of physics have not yet been unified into one complete theory of quantum gravity. Without that unified theory, claiming to know exactly what existed before the Big Bang isn't just difficult, it's currently beyond our scientific limits.
Section 4. Time and other alternate universes.
This lack of a unified theory absolutely opens the door to some mind-bending scientific hypotheses. Honestly, the most surprising idea is that time itself might have been born at the Big Bang. We usually think of time like a ticking clock, right? First one event, then another. But according to Einstein, space and time aren't separate. They form a single structure called space-time. Therefore, the concept of before might be completely meaningless if time itself was born at that exact cosmic moment. It's exactly like walking to the North Pole and asking someone, hey, which way is further north? The question itself stops making sense because the direction of north no longer exists in that context.
But what if there was something before? Well, some mathematical models suggest a cyclical or bounce universe, where a previous universe contracted and then expanded into ours. Others suggest the multiverse, this idea that our universe is just one tiny piece of a much larger, grander structure containing many universes. Now, it's really important to note here that while the internet loves to hype up claims that scientists have somehow found other universes, these remain fascinating but completely unproven theoretical models. They are possibilities being studied in mathematics, but they are not established facts.
Then there's the deepest question of all. Where did the energy come from? In our daily lives, everything has a cause. A chair was built by someone. A star was formed by matter and physics. So what actually caused the universe? While science explains the mechanics beautifully, the pure existential reason for energy existing at all remains a profound philosophical mystery. Physics is incredibly successful at answering how the universe developed, but why is there something rather than nothing? That's a question that science alone may not be equipped to answer.
Section 5. The Universe's Story and Us.
Let's trace how all of this built our reality, from subatomic particles cooling down to the formation of the very solar system we call home. The universe started impossibly hot, but as time passed, it expanded and cooled. After about 380,000 years, it cooled just enough for electrons to bind to nuclei, forming the first neutral atoms. This finally allowed light to travel freely, which is that cosmic microwave background we still see today. Over millions of years, gravity pulled matter together into giant clouds of gas. Stars were born. Galaxies formed, and eventually our own solar system took shape.
Scientists estimate this entire process has been going on for about 13.8 billion years. To put that massive scale into perspective, if this entire timeline were a 24-hour clock, human history would only appear in the final fraction of a second. We arrived incredibly late to the cosmic party. I mean, we basically showed up in the last few milliseconds just to start asking all the complicated questions.
But hey, don't let that make you feel insignificant. The stars formed first. Inside those stars, heavy elements were created. When those stars exploded, they scattered those elements across space, eventually forming planets and providing the literal building blocks for life. Every heavy element in your body was forged in the heart of ancient exploding stars, proving that we are intimately, physically connected to this cosmic narrative. We aren't just observers standing on the outside, we literally are the universe experiencing itself.
Section 6. Science's biggest unsolved cosmic mystery. Even with everything we know about our star stuff origins, the very opening chapter of reality remains hidden behind a veil. So will we ever fully understand what happened at the absolute beginning? Possibly. Future technology and observation methods might one day lift that veil, giving us revolutionary new ways to understand space, time, and reality itself. Scientists are building more powerful telescopes, advanced particle accelerators, and highly sensitive gravitational wave observatories. These tools might capture even fainter signals from the early universe. Perhaps one day we'll finally develop a complete theory of quantum gravity, unlocking the answers to whether our universe is alone or if time truly had a beginning.
But it's also possible that as we learn more, our questions will only get deeper. And honestly, that is the true beauty of cosmology. Science isn't about having all the answers immediately. Not having a concrete answer isn't some failure of physics. It's the beautiful, thrilling frontier of scientific inquiry. Today's we don't know is exactly what fuels tomorrow's discoveries.
We have successfully mapped out 13.8 billion years of history, yet that very first chapter remains one of the universe's best-kept secrets. I want to end this explainer by leaving you with this final, provocative thought to ponder, and I highly encourage you to keep questioning the incredible universe around us. If there truly was something before the Big Bang, what could that something possibly be? Thank you so much for exploring this fascinating topic with me today. Keep looking up.